Smile, you're on camera. No, I'm kidding, it's just a screen. Function trill. Let me create a random matrix of 3 by 3. If I want to keep everything above the main diagonal and remove everything below, I'll use the function trill. Or actually the other way around. If I want to keep everything below the main diagonal and remove everything above, I'll use the function trill. So again, trill, what it does, it will keep the main diagonal and everything below, and it will remove whatever is above the main diagonal. So it will set them as 0. What if you want to keep everything above the main diagonal and remove whatever is below? Jack is already, yes. Trill what?
A prime. Trill A prime.
Trill A prime. Let's see what A prime looks like. So if you want to keep everything above, means you want to keep these elements.
Do you transpose it?
You could, well, prime would basically transpose them, right? So it kind of does the job. Maybe after trill you do another prime to get them back on the same position that they were. Let's see. Trill A prime and then another prime to get them back up to the original position. Does it make sense? We did an A prime, rows became columns, right? We did an A prime, so 9, 9, 1 instead of being here is now here. So instead of being on 1, 2, it's on 2, 1 now, right? When you do a trill, you keep everything under and remove everything above, right? So when you do trill of A prime, all right, let's do this. CLC, this is A prime, this is trill of A prime, right? And now, if you do another transpose, what happens is that these will come, or the first column then becomes the first row again, right? So it goes back to the original position. Does it make sense more or less to everyone? You're doing good? The other way is to search for it, trill MATLAB above main diagonal. Well, actually there's a better way. Let's see, trill means lower triangular part of a matrix. If you want the upper triangular, if you go down, you'll see there's another function, triu. This is the upper triangular. So instead of doing all the primes, you can use triu instead of triL. Does it make sense? So basically, if you do triu of A, you get the same thing. You don't have to do trill of A prime, then again A prime. Triu will do it for you. Again, your best friend is Google. Search for everything online. I'm trying to get rid of that light. Okay, is it better?
Yeah.
So this is triL and triu, lower triangular and upper triangular parts of a matrix. Does it make sense? Yes.
So, how would you do the figure 12 part B? How would you do like a certain vector that has, like would you times it by -3? Like instead of it being 0 when you put in trill, would you just times -3 times trill? Do you understand?
So you want -3 to be,
To be the,
okay. So yeah, so you can do -3 times ones
okay,
and then do trill,
so,
right?
yeah.
Because what you are looking for, let me see, I can add, well, at some point I could have added the camera to show this, to record myself and the board. I didn't do that, so now I don't know if I can. Probably I cannot. So what Jen, right? So what Jen is asking is, how can we create this?
Actually, what I'm asking, so can I just tell you what the matrix is?
Sure.
So it's, the first row is 1, 2, 3, 4. Second row is -3, 1, 0, 0. Third row is -3, -3, 1, 0. And the last row
Okay.
is -3, -3, -3.
Sure. So we have 1, 2, 3, 4.
Right.
We have -3, -3, 0, 0,
It's -3, 1, 0, 0.
-3.
And then -3, -3, 1, 0. And then 3 -3s. And then the last number is 1.
All right. Let's break this down. What I see here is 1, 2, 3, 4 on the first row, right? So that's probably an override on whatever matrix that we have. So let's leave that aside. What I have here is I, right? I have ones on the main diagonal. With I, I'll have zeros everywhere and 1 on the main diagonal, right? Then I have -3s on the lower triangular area. I have trill. Trill will give me -3, -3, -3, -3, and everything else -3 and 0. I want one diagonal below the main diagonal. So let me start with creating a matrix A with -3 times 1s of 4 by 4, right? Let me create this first. If I do trill of A, what it does, it will keep the main diagonal and everything below, and will remove every single one. That's good, but I don't want the main diagonal either, right? I want the main diagonal to be 1, and I cannot go from -3 to 1. So that's an issue. In order to keep whatever is below one diagonal below the main diagonal, you could do trill of A, comma, -1, because you want to go one diagonal below the main diagonal, right? If I do trill of A, comma, -1, it will keep whatever is below the main diagonal, like one diagonal below the main diagonal, and it will remove everything above. Does it make sense so far? If I do trill of A, +1, it will keep one diagonal above the main diagonal and everything below that. Is that clear? So you can go one diagonal above, you can go 2 diagonals above, 3 diagonals below. You can do whatever you want with it. Just that comma -1 means one diagonal below. Comma +2 means 2 diagonal above the main diagonal. So that's how you create. If I do B equal to trill of A, comma, -1, I, for now, created this part, right? I created this part. Now I want the ones. C is equal to I of what? I of 4. I of 4 or I of 4 by 4, it doesn't matter, right? So now I have created this, I have created this, I have the zeros, it's all right. I don't have these ones for now. Let's do this. Let's add B and C. If we add B and C, what happens? Which part of this matrix is going to be created with that? If I just do B plus C.
All the negative 3s, the 1s and zeros.
I'll have all the negative, I'll have all the ones, and I have all the zeros. I just have to overwrite 1, 2, 3, 4 on that matrix, right? So I would do D is equal to B plus C. So now I have the negative 3s, I have the 1s, I don't have 1, 2, 3, 4. So what I do is I overwrite the first row. Overwrite the first row how? D of 1 and all the columns. So the first row is equal to 1 through 4. Basically, I overwrite the first row with 1, 2, 3, 4. So basically, break the problem into pieces and then add them together. Make sense?
Yeah, thank you.
Of course. Any other question? Not at the moment. Okay, not this one. There was one thing which remained from last session on the plotting. Let's take care of the subplots now. But let's merge the new session and the previous session and do it both together. So far, whatever command we have created or we have executed, they were in the command window, right? Whenever you close that MATLAB, they're all gone. You don't have them. You don't save it, right? What if you want to save it? What if you want to use whatever? Because hopefully you want to have a code that you'll use later, right? If you want to save things, rather than just writing in the command window, you can open up a new script. See over there? A new script. You can open up a new script, and then whatever command you were writing in the command window, you can just write them in the new script here. It's exactly similar. The only difference is every time you hit an enter, it will not execute the command. You can write a bunch of commands together and then run your code, run your script, and everything will be executed together. Other than that, everything is the same. This script is exactly like the command window. The only difference is you will save your script, you will have it later, you can go back to it, you can change things, you can make sure that things are correct. Like everything that I do, I'll do it in a script. Even if I want to create a plot that I needed once, I write a script for it. Why? Because you don't know what happens. Maybe you want to change that plot. Maybe a week later you remember that, okay, I got to check whether I used daily or weekly or anything else. If you just have a plot, it's hard to check. But if you have a code that created that plot, you can go back to your code and check everything, fix anything, double check everything, and those things. All right. So again, I do CLC. What does CLC do? What is the functionality of CLC? Clean the, clear the screen or command window. Clear would do erase every variable that I've defined. So CLC clear. Again, if I put CLC clear and hit enter, everything will be gone. In a script, it will not. It will not execute that command, not yet. I will define, so this is similar to what we did last session. Remember we did plot of cosine and sine and things? Let's do it again. Linspace will create what? What is going to be x? Is it a vector, matrix, scalar? What is it? Vector. How many elements do you expect? 100 elements, right? 1 by 100, that's what linspace gives us. Then we did plotting, right? Plot x comma sine of x. What if I want to plot x comma sine of x with a red dashed line?
R dash dash.
R dash dash, right? Within quotes, within apostrophes. And then there was a question of how the hell do I know, is it dash dash or dash dot or dash or whatever? Right here in the command window, you put help plot. And then you come up here. If you want any color, this is how you get it. If you want it to be points or circles or etc., it's right here. If you want it to be solid line, just a dash, dotted line, the colon, dash dotted and dashed, etc., it's right here, right? So if you want to have a sine of x with dashed line red, that's how you do it. So this is sine of x. We wanted to plot cosine of x on top of this, on the same plot. What was the command that we used? Because if I do another plot, it will erase the first plot. It will plot something else, right? It will plot cosine of x. The first one is gone. Hold on. Right? Hold on. So hold on will keep the first plot, and then you can plot on it. Once you put hold on, everything else that you plot will be on the same figure, right? So it doesn't matter, you can put sine of x, cosine of x, tangent of x, etc., etc., etc. It will be on the same figure until you put a hold off. Until you put a hold off, everything will be in the same figure. You don't need to repeat hold on several times. Once is enough. Plot x comma cosine of x. I want it with a green dotted line. But I also ask you, so I have x being 1 by 100. What's the size of cosine of x? 1 by 100, right? It would be cosine of each point. Now, when you do plot of x comma sine of x, you get a continuous line. Whereas your x is not continuous, right? It's 100 discrete points. What happens when you do plot of x comma sine of x? It will linearly connect all the dots, all the points. Because you have 100 points, your lines are going to be very small, so your curve would look like to be smooth. right? Now the other thing that I can ask you here is, instead of using lines, show those points with circles, with magenta circles. I can ask you that, right? What would you do? Plot x and cosine of x with magenta circles. How would you do that? M MO, right? M stands for magenta and O for circles. So I would do plot x comma cosine of x comma MO. M for magenta, O for circles. That's what you have here. If you want to do x marks, x. Do pluses, plus sign. All right. Then the other thing that we talked about last session was how to put x labels and y labels, right? Because right now when I plot this, all right, let's do this now. Before we put x label, y label, etc., let's plot this very quickly. In order to make that plot, we have to run this script, right? You have to run the script. Because so far we had commands, and commands have not been executed. Commands are written, not executed. In order to do that, do you see this green triangle here? Run. If you hit that, first thing that you need to do is you need to save this script. The script has not been saved yet. You have put commands in it. You have not saved it yet. So you got to save it. So you gotta come up with a file name. See, there's a file name. You gotta come up with a file name. If you remember from last session, we couldn't save in system32 in this directory because I don't have authority. We can go to desktop. On the desktop, I can call this, I don't know, plotting. Can I call my file name plot? I see Jack is inclined toward no, but he is not going for it for now. Can I call my script plot? No. Why? Then yes.
You can get, you have to put plot and then my name.
Exactly. So what we have here, we have a function called plot, right? We have a function called plot. If I call this script plot, MATLAB will confuse the function plot with your script plot. Remember we did this with variable names? Same as file names or function names. You should not define your variable names, function names, script names, the same as the built-in functions of MATLAB. Because if you do, MATLAB will not run the built-in function. So plot is a no-no. If you start with capital P, then that's fine. If you do plot lowercase, that's a no-no because that's the built-in variable. So I kind of save this. Then the issue is I saved this script on my desktop, right? Remember I changed my directory to desktop? So when I try to run this, let me cancel this for now. When I try to run this, this script is not within my current folder. So MATLAB cannot find it. You got to change your current folder to desktop. That's one way to go. The other way, when you run it, it will ask you, all right, plotting.m is not found in the current folder or on the MATLAB paths. So basically it's for now unknown to MATLAB, whatever this script is. To run this file, you can either change the MATLAB current folder or add its folder to the MATLAB path. What does it mean? You can either change the folder and then you'll go to the desktop where the file is, or you can add it to path. When you add it to path, it means that you have access to that other path, which is the desktop. Does it make sense to everyone? So let me change folder. As you can see, this is my desktop, and I have a script plotting.m in my desktop folder. And then this is my plot. This was my sine of x. This was my cosine of x. I have two things on the cosine of x, right? I have, if I zoom in, do you see these dots, these green dots? Those small green dots? Do you see them? Do you see these small green dots? And these are the magenta circles. This is what we defined, right? If you look here, green dotted line and magenta circles. That's what we asked for. And that's what we got. Now, first thing first, x is between 0 and 7. So this part is empty, white. I don't like it. Let's cut the axes. How do we do that?
Between 0 and 2 pi.
From 0 to 2 pi and from -1 to 1. But what's the command that we use for it? Axis. If you keep not answering, what we are going to have to do is we are going to have to take a quiz. That's how it works. So when I do axis, I first define where is the range of my axis for x, and where is the range of my axis for y. So it's between 0 and 2 pi for x, between -1 and 1 for.
Yeah. Why you don't have anything at the number 6?
You can just leave it empty, doesn't matter.
Okay.
Then I want to define labels. For the x label, what's the command? What? X label. Let's just call it range of x for now. For y label, it is y label. Maybe trick function values, I don't know.
I'm sorry, can you tell me again what axis 0 times 0, 2 times 5, -1, what does that represent again?
Sure. So it's first the x-axis. What's the range of x-axis? That's between 0 and 2 pi.
Okay.
And then what's the range of y-axis? That's between -1 and 1.
Okay.
Does that make sense?
Yeah.
Again, we also have, so we are recording all this. You're on camera, smile. I'm kidding again. But your voice is all recorded. So be careful. Anyway, so the videos I'll share with you, and you can go back and watch if you need it. So X label, Y label. Do you see any mistake in there? Typo? We're gonna have to fix it. But let's not fix it first. Let's get an error so I can show you how to get from your errors to where the error is. The other thing that I want to put in is so for now we get all the lines. We don't know what each line is, right? So you can get, you can put legends, right? You can put legends to show what is what. So legend, the first thing that we plotted was what? The first thing that we plotted was sine of x or cosine of x?
Sine of x.
Sine of x. Perfect. The second thing that we plotted was what? Cosine of x. Did we have a third thing that we plotted?
Yeah.
We did, right? So we had cosine of x with green dotted line and cosine of x with magenta circles. Bless you. Alright, so I will run this now to see what happens. If I run this, you will get an error. Undefined function or variable y label, which is E and L should be swapped, right? Error in plotting. Plotting is the name of your function, right? The name of your script. Where in line 8. So when you want to fix this, if you click on line 8, it will take you to where the error is. And this is already giving you what the issue is. The issue is that you have an undefined function or variable y label. So you know what the issue is, and you know where that issue is. If you just click on this, it will take you to line 8 where the error is. And then in line 8, you know x label is, there is a typo in x label, so you fix it. Now if you run this again, you will have a plot. You will have a sine of x, you'll have a cosine of x, and then you'll have a cosine of x, right? So sine of x, the first one was a red dashed line. Cosine of x, the second one was a dotted line. And cosine of x, the third one was just the circles, just the points, which is what we have. Perfect. I would ask you, what happens if I just not define the third one in legend?
We'll make a name for it.
No, it will just show the first two. It will not show anything about the third one. So if I run this, it will show the sine of x with a red dashed line, cosine of x with a dotted line, green dotted line, and nothing with the circles. That's the legend. Does it make sense so far? Perfect. Now, let me open another script. Now in this script, first of all, if I want to recycle some of my previous code, now it's easier because I can just simply copy and paste from here. Right? Now in this one, what I want to do, instead of having sine and cosine and everything in the same plot, I want to have several subplots in one figure. Does that make sense? So I want to have a figure, and I want to have subfigures in this. Now I want to do this. For subplots, the function is of course subplot, right? What the function subplot needs is first, how many rows of subplots do you have? You got 3. How many columns of subplots you have? You got 2. And where in this are you? This is 1, this is 2, this is 3, this is 4, this is 5, and this is 6. I know it's confusing because MATLAB is supposed to be column-wise, so hopefully it would have been 1, 2, 3, 4, 5, 6, but for any reason, this is 1, this is 2, this is 3, this is 4, this is 5, this is 6. If you have a 4 by 2, you would have 7 and 8. Right? Does that make sense so far? Perfect. So what I want to do now, instead of having a 3 by 2, I want to have a 2 by 2 because I want to do sine, cosine, tangent, and cotangent. So 1, 2, 3, 4. Sine, cosine, tangent, and cotangent. All of them between 0 and 2 pi. Negative 1 and 1. Tangent and cotangent, they can go all the way to infinity, right? As they merge to pi, they can go to infinity. Pi and pi over 2. But anyway, I don't want to show infinity because that will not show anything. Now, again, I do CLC and clear. Remove everything. Again, I can recycle some of my previous code. I don't have to write everything again. So what I will do is I will copy this and I will paste it here. So this x going between 0 and 2 pi is going to be used for sine, for cosine, for tangent, cotangent, for everything, right? So x is a general thing. Let's keep it here. The first subplot is going to be sine. So let's do subplot. Did we decide to have 2 rows and 2 columns? 2, 2, 1. That was the first subplot. I wanted to plot sine of x in the first subplot. Do I need to hold on? No, because in each subplot we are plotting 1, right? Sine of x in the first subplot, cosine of x in the second subplot. If you want to have several things in the same subplot, then you would need hold on. If you don't want to plot like several things in the same subplot, because each subplot is like a separate plot, but the subplot you just put it in the same figure. We'll get to it. Just hold on a second. So we want to plot x and sine of x in the first subplot. We want axis to be between 0 and 2 pi, and we want x label and we want y label for the first subplot. So I just copy and paste them here. I want them to go between 0 and 2 pi and negative 1 and 1. That's what I want. And the y label now I want it to be sine of x. I don't want a legend now because the first subplot is just sine of x. I just put it as sine of x. Perfect. So that's my first subplot. The second subplot I want it to be what? Cosine of x. So again, I just copy and paste everything. Instead of 1, now I have 2. Instead of sine of x, I have cosine of x. And here I have cosine of x.
The color is not
I can change the color to whatever I want. If I want it to be green dotted line, I'll put it as green dotted line. In the exam, in the homework, I will specifically ask you, I want this line to be magenta dash dot line. Then you will have to put M dash dot. So that's the second one. For the third subplot, again, that's 2, 2, 3 now. 2, 2 remains constant because that's 2 rows, 2 columns. 3 means I am here. Now I am plotting tangent and for the last one I again copy and paste everything. Now I am on the fourth subplot. I want to plot cotangent and I have no idea what cotangent is in MATLAB. COT. Now, if I run this, first thing that happens is what? I'll have to call, or I have to give this function, this script a name. This script doesn't have a name right now. So plotting 2. I save this, and this is going to be my. I have 4 subplots. I have sine of x on the first one, cosine of x on the second one, tangent on the third one, and cotangent on the fourth one, right? I don't like that green dotted line. This is not really visible, so let's change that. Instead of a green dotted line, I go with a black dotted line. That's more visible now. For this, I go with a magenta dash dotted line. And for this, I'll go with a blue solid line. For a blue solid line, you can put a dash or you can just put B. If you don't put anything, that's a solid line. See how easier it is to fix things? When you do it in command window, you got to do copy and paste everything again and run again and again and again. Now you just go there, you fix things, and you run, and that's it. Does it make sense? Why don't I give you a couple of minutes to work on this? Just walk around, let me know if you have any issues. If anything is not clear, let me know, and we'll fix it. Is that it? Yes. One thing that I see the difference between is that you don't have a range for x, for x and y. So you're going between negative 60 and 60, and you're going between negative 5 and 10 to the power of 15. Right. So put an axis, then you constrain your axes. Then you'll have the same plot, because they are the same plot. But at some point, or over either pi over 2 or pi, they go, or they merge toward infinity, right? So you can't see them. Did you all get them to work? Awesome. Do you have any questions, concerns, comments? Do you want to have a quiz on Friday?
No.
Kind of want to, okay. You might. So make sure that you review the materials that we covered for Friday. Yes?
Are the quizzes usually 4 questions, or are they going to get longer?
There will be various number of questions. Might be 1, might be 5. The timing is going to be proportional to the number of questions. Yes?
And will
they all be multiple choice, or will they be?
For now, they are all multiple. As we proceed, we will have questions that it's quickly you can run them on MATLAB, like in 1 minute or less. I want to now move to functions, but I don't want Francisco to miss this because this is very important. So, a quick overview of the scripts. The scripts are completely similar to what you have in the command. What would have happened if you had run this on the command window? First, you had clear and CLC, right? So you would clear the command window, and you would clear the workspace, right? So there's nothing on the screen, nothing in the workspace, nothing on the screen. Go. Then you had defined x to be between 0 and 2 pi, 100 values. So x is now in your workspace. It's similar as if you had it in your command window. Then you did subplot of 2, 2, 1. What it does, if you run this only, if you want to run this only, what can you do? There are two ways, maybe more. You can just copy and paste it in the command window. That's one way to run it, right? One way to run is just to copy and paste that line in the command window. So Control C, Control V, it will create a figure, and it will create the first subplot in that figure. So that was one way to run this line. The other way is just select the line, right click on it, and evaluate selection. Select the line, right click, evaluate selection. That's another way that you can run that. Does that make sense so far? Can you run several lines together? If you want to execute several lines together, what do? Select them all. If you want to do copy and paste into command window, be my guest. Otherwise, just right click and evaluate selection. What happens is that only the first subplot is created, because that's what we asked for, right? Does it make sense so far? So it's completely similar to command window. So you have X here, you know, if you just run this, you don't have anything on the screen because of the CLC. You only defined X value, which is here. If you define other variables, they will all be shown on the workspace. For example, if I do y is equal to sine of x, z is equal to cosine of x, y is equal to tangent of x, and zz would be equal to cotangent of x. And then what I would do, I would get rid of this sine of x and just replace it with y. Cosine of x, I just replace it with z. They are the same, right? Because I defined z to be cosine of x. So I can just replace cosine of x with z. Tangent was y, cotangent was zz. Now if I run this, what do you think the variables in my workspace would be? It's going to be x, y, z, y, and zz, right? Those are the five variables that I defined. Everything else is the same. You get the same figure. It's just the variables that you define are going to be shown in the workspace. Is that clear so far? Perfect. So now this is called the script. We created a script. We have that script. You can email it to yourself, keep it for later, that's yours. You have it. You can run that script several times. If you have a big script in which you have these several lines several times. So let's consider that you want to plot this several times in various scripts. As we talk, you can recycle. So you can copy and paste your commands into new scripts. You can do it. But if you want to repeat one functionality several times, like sin of x is a function. You can evaluate sin of x for any value, for any vector, for any matrices, right? You created sin of x because you want sin of x to be useful if you want to repeat this calculation. If you want to evaluate sin of x several times on several variables, you have a function that will do that for you. So when you want to repeat something, repeat the functionality, you should create a function rather than a script. Because when you have a function like sin of x, you can just call that function, give it some input, get some output from it. Right? You don't have to copy and paste all the things that are in the function anymore. Does it make sense more or less? So basically when you want to repeat one functionality several times, you create a function with an input or with a set of inputs and with a set of outputs. Every time that you call the function, you'll give it the inputs, you'll get the outputs from it. You don't care what's going on inside. You don't have to copy and paste anymore. You just call one function, get some value out of it, you're done with it. Like sin of x, like cosine of x. These are all built-in functions, right? So someone created a function that's within MATLAB. Every time that you want to calculate cosine of x, you just call cosine of x, give it some value, get some value out of it, and you're done with it. Does that make sense? So functions are like black boxes. They get some value, they give you some value, and done. Let me give you an example. Well, let me first create a function for you. Let's go over the function together, and let's practice this together. Function always start with function. You write the function. Then you define what your output is. My output is y. Then you define the name of the function. I call my function name sum2. I cannot call it sum because sum is already a built-in function, right? And then I'll give some inputs to this, x comma z. And then what I want this function to do is to add x and z and give me y. X plus z is equal to y. So my function, what it does is that it takes x and z, add them together, creates y, and report y back to me. It's a very simple, I know this is a stupid thing, a stupid function, why do you want to do that? But just to show you how to create functions. So function, name of the output equal to name of the function, parenthesis, all the inputs, and done. And then there are calculations within your function. Then what you'll do for any function, you have to save them. Any function or any script, etc. You have to save them. You'd save this. Then what happens is that the file name comes as the name of the function that you define. Don't change this. Name of the file should be equal to the name of the function. It will automatically come as the name of the function. Don't change this. Just keep it as is. See, right now I don't have a file with the name sum2. As soon as I save this, I'll have a file with name of sum2. You see the difference between this and this? This is a function, like fx is a function. This is a script, so you don't really see that fx. So the difference also is here. Now, when you want to call your function, what you'll do is you'd say, okay, let me clear everything. Now that I want to call my function in the command window or in the script, you can do either one. You can call your function. You can say y is equal to sum2, and then you give it two inputs, 5 and 8. What do you expect to get as y? 5 plus 8 is what? 13. So y is now equal to 13. Look into your workspace and look into your command window. Y is equal to 13. So whatever two values that you give to this function, it will add them together, put them in y, and report y back to you. Yes?
Why would you want to do that instead of just saying y is equal to x plus z and then defining what x and z are? I mean,
We can. This is we are just defining a function for now.
okay.
It's just a simple, stupid calculation. I just want you to get to know functions. We'll get to that. We'll get to more complicated functions as we proceed. Now, I want my function not only to add the two together. I want my function to multiply them together as well. So now I'll have two outputs. I'll have the summation. I'll have the multiplication, right? So it will take x and z, it will add them together, and it will multiply them together as well. M is equal to x times z in the function. X plus y is equal to y, x times z is equal to m. I save my function, and then I call my function again. I expect to get what? I expect to get 5 plus 8, 13, 5 times 8, 40, right? Let's call it and see what we get. I get 13, but I don't get a 40. Why do you think that is? You have to have an output variable m. You define m in your function, but you never ask for it, right? Do you think m is already calculated within the function? We have a no, we have a yes. Yes, that is calculated, but never reported back to you. Remember when we did semicolon and not semicolon? Let's not put a semicolon in. I just want you to see that both lines are evaluated, but the second line, m equal to x times z, is never reported to you. So you change this, you got to save it first. Let's save it, and let's call it again. See what happens? Y is equal to x plus z is 13. M is equal to x times z is 40. But what is this one? Why do we have two y equal to 13s?
Because you defined it twice.
We defined it kind of, yes. So we have these two lines, which are these two. And then by defining twice means that I defined y equal to sum 2 of 5 and 8, which is this one now. So this one is basically the result of this line. Does it make sense? Is it clear? Nicole, are we good? More or less? Let's do this. let's run this with several different options. If I put a semicolon at the end, I'm still running my function, right? Only y equal to 13 and m equal to 40 will be shown on the screen. Because those are the two lines that were executed. They were shown on the screen. Y equal to 13 is now, the second y equal to 13 is now not written because we have a semicolon here. So this line will not write anything to this. Let me put back the semicolons here and here, and then save. And let me run this again. It will not write anything to the screen. Yes?
Why is there no n in the workspace, like on the right side of my column?
Exactly, that's the point. We are getting to this. So m is calculated. M is not reported. You don't have m in your workspace. Because whatever happens in your function stays in your function. Unless you report it back. The only variable that you're reporting out of your function is y. So m is calculated in your function, never reported. Does it make sense? So you don't have m in your workspace. If you want to report both y and m, you will have to ask for both of them. Y, comma, m. This is important. Outputs are within brackets equal to name of the function, and inputs are within parentheses. Outputs are within brackets, inputs are within parentheses. Now that I'm asking for both y and m, I save this. When I run this function, now I ask for both y and m. See again, there is no m in my workspace right now. As soon as I run this, I'll have an m in my workspace. See m? Does it make sense? So now this is how you define a function. Let's just quickly go over a few things. We are going to get back to the concept of function next session, because functions are very important. I want you to know the functions. I want you to be very familiar with functions. These are very important. What happens if I just ask y equal to sum2 or to sum, or let me do this. Let me first do clear and CLC. Now I don't have anything. Now let's go back to this. What happens if I just ask for y? It will just give me y. See, only y is given to me because I didn't ask for m. But if I want m, only m.
Like only m? You just remove the semicolon from the m one?
Sure.
And then add a semicolon to the sum2 at the top?
No, that wouldn't work. So you mean if you don't have semicolon here, but you have a semicolon here,
You keep that one up there, but then when you type it in the bottom script, you add a semicolon like you did right there.
you want to change in here or in here?
No, in the bottom one. You leave the semicolon at the top.
So let's put the semicolons here.
No,
Okay. What?
take it off the m.
Take it off of the
Yeah,
m.
just that one.
Okay. All right. So what you say is, let's do this. It will show m to me. Yes, m is equal to 40. But m is not in the workspace. M is just shown on the screen. M is never saved as a variable. So let's put the semicolon back here. And let me, again, any change that you make in the function, save it first. And let's go back here. So we had y, comma, m. If we do this, we get both y and m, right? If you only want the second one, you don't want the first one, you put a tilde instead for the first one. So brackets, tilde, comma, m, it means that I don't want the first one, I don't care about that, just give me m. The issue is we already have a y in my workspace. So let's clean that or clear that. I right click on it and I do delete. So I don't have a y anymore. Now if I run this one, the only variable that I will have in my workspace is going to be m. What I said is that I don't want the first one, tilde, comma, m. I want the second. The other thing that I wanted to talk to you about is, we still have 4 minutes. The other thing is, what matters with these names is the order. The order of the variables that go in and the order of the variables that come out, right? So if y and m, if y is summation and m is multiplication in the function, and if here I ask for m comma y sum 2 or sum 2 of 5 and 8, m will be addition, m will be 13 and y would be 40 multiplication. So it doesn't matter. So see, y is 40, m is 13. It doesn't matter what your names here are. The order is important. So the name of the variable, whatever you have here in the function, only matters in the function. When you get outside the function, the only thing that matters is the order. So the first output is summation, the second output is multiplication, and that's about it. Same with inputs. Let me define another one. D is equal to x divided by z. Right? So I have y, m, and d as outputs. And then again, you add something to this, you save this. Done. So you get my d 5 divided by, let me do 10, it's easier. So I have m as summation, which is 5 plus 10, y as multiplication, and d as 5 divided by 10, right? So I have summation is 15, multiplication is 50, 5 divided by 10 is 0.5. Now if I do 10 comma 5, I'll have 10 divided by 5, 2. And to make things more complicated, instead of giving it numbers, I have variables, right? I have d equal to 2, I have m equal to 15, right? I have d equal to 2, m equal to 15. If I put d comma m, what happens now? It will take d as 2, it will take m as 15, will give 2 and 15 to the function, will report the summation, will report the multiplication, and will report the division. And then it will replace d and m. That's enough for today. M was 2, D was 15. M is now 17 because 2 plus 15 is 17. Y is now 30 because 2 times 15 is 30. 2 divided by 15 is 0.13. All right, thank you so much. I'll see you on Friday. We might have a quiz, so please have a look. I will upload the video, or I'll give you the link to the video soon. Thank you.